Okay, so this is a video of a limit review. Let's first look at the notation. If you have, this is limit x going to 2 of f of x. So we want to read as limit of f of x as x approaches 2. That is how we read this expression. And so let's just take a specific f of x. So let's find limit x going to 2 of x cubed plus 3. So which means the question is as x approaches 2, what happens to x cubed plus 3? What happens to this expression approaches what number? So this is the number which is the answer to this limit problem. So as a shortcut, we could just plug in. So that is the method 1. Method 1 is plug in x equal to 2 in x cubed plus 3. So you could put 2 here. We will have 2 cubed plus 3, which is going to be 8 plus 3, which is 11. Right? So this is method 1, where we could just plug in the x value into the function f of x to get the limit value. All right, so we're going to see the numerical method, and I'm going to use Desmos for that. So we're going to move on to Desmos, and so I've just created a table here. So go to this table, and if you click, and you can create the table, and then or you could use a graphing calculator for this. So we're going to put x, and then we're going to put the function. We're going to put x cubed plus 3. Okay, x cubed plus 3. So we have x as x approaches 2. So this is what we're going to try to do. As x approaches 2, x cubed plus 3 approaches what? Right? So we're going to make the x values go towards 2. So we're going to choose x values here because it goes towards 2. We're going to choose very, very close to 2. I'm going to choose from the right side. So we're going to start from 2.1. And then 2.01, 2.001. So these are numbers extremely close to 2 and approaching 2 from the right side. So let's see more. 2.0001. So we can see that these numbers are approaching 11. And then let's do one more. So it's getting even closer to 2, and then so we can see that the values are approaching 11. So same way we wanted to try to do from the left side of 2. Left side of 2, I'm going to start from 1.9, and then from 1.9 it's going closer to 2. So 1.99, 1.999. So we can see that it is like going 10.9999, so which is approaching 11. So we still have the answer to be 11. Right? So you could do the table. The table is the numerical approach where we kind of choose x values and then see what happens to the f of x values, and then conclude the answer 11. Okay, so let's see one more example of the numerical method. So let's find the left limit. Limit x goes to 3 minus. 3 minus is the left limit of let's say x power 4 plus 2. So what happens to the question here is as x approaches 3 from the left, what happens to y? Here y is x power 4 plus 2. Y or f of x is x power 4 plus 2. So we're going to choose the use the graphing calculator. So I'm going to open up the table, and we're going to find use x, and then we're going to put the y value, which is the f of x value here, x power 4. Okay, so now we're going to choose x values approaching 3 from the left side. So approaching 3 from the left side, which means if I have a number line, if I have 3, so x is going to approach 3 from the left side. So we're going to start off by choosing x equal to 2.9, which is smaller than 3, and then move closer, to 3. So I'm going to choose 2.9. Okay. Okay. Right. So 2.9 is 72. We're going to get even closer to 3. So 99. And then next number will be 2.999. 2.9999. Right? So we can kind of see a pattern emerging. And then the y values are going towards 82.99. So it's actually approaching 83. So maybe one more number. So it's becoming 82.99, and then it become 999. So it's going to become 83. So this whole thing approaches 83. So as x approaches 3 from the left side, the y value approaches 83. So if we're going to do the right limit, let's do the right limit. Right limit is x approaching 3 from the right side. Notation is 3 plus x power 4 plus 2. So x approaches 3 from the right side. So you have 3, and x approaches 3 from here. So we're going to start choosing maybe 3.1 and then move closer. So let's put this. Okay. So we're going to start off with 3.1. And then it's getting closer to 3, so 3.01, 001. So we can see that it's actually moving closer to 83. And as we get closer and closer to 3 from the right side, the y value becomes closer to 83. So the limit here is 83. So the left limit and the right limit equal to right limit equal to 83. Of course, if you plug in the value, if you plug in x equal to 3 in x power 4 plus 2, we will still get every 3. So if plug-in works, that is the shortest method, and then if not, we could always do numerical work. So 83 is the left limit and the right limit, and the function value. It is also the function value.